Okay, hey guys. All right, let me just get straight to it. So, gonna open Workbench. Okay, it's gonna load, obviously. I'll try to make this as short and sweet as possible. Okay, so the first thing you're gonna see, it's not fully loaded yet, but I think basically you should always assume, or the easiest way to do this is to basically just assume that your material is going to be stainless steel. So the first thing we're going to do is we're going to put a geometry on the screen. This is just how I do it. I always name it 3D. 3D Geo. Okay. Now that doesn't have a part in it yet. So then we're going to get our static structural. We're going to put it right there. All right, and then we're going to open engineering data just ahead of time. So you just double click that. All right, so now we want to input our geometry. So you're gonna right click, and then you're gonna import geometry. So I'm gonna go with my file. So I'm gonna do bracket co IGS. You can see right here on the right side, geometry file name. You want to make sure that says IGS. All right, and then you'll click and hold this and drag it to geometry there. Okay, so now it check marks. The next thing we'll do is we'll go to engineering data. And this is where you'll set all your data. So this says structural steel, which is fine. Derived from young homologous, you want to make sure it's 2e to the 11th. That's in PA. So it's 2 point something in GPA. Bulk homologous, shear homologous. Okay, that looks all good. And the tensile strengths. If you use a different material, these will have to be different. Otherwise, you're good. So now we won't use that anymore. Now we're going to go and double click model. All right, and this is going to open up our mechanical window. And so mechanical is basically it's where you kind of do all your setup for the simulation. Mika was talking about like some really complicated stuff, simulations, but you don't really need that. So this is what my bracket looks like. Had some rounding corners and stuff to reduce stress. Probably could have rounded that at the bottom, but it's all right. So the next thing you want to do, you'll see this out. If you don't see this outline, so say this is not here and you just see this lighting or not even that, you will go to display, or not display. Where is it now? Selection, not there. Model. Home. Right. So you'll go to the home tab. You go to manage up here at the top right. And you'll go to, there's an outline button. Yeah, right here. And that'll bring up the outline, okay? I had to figure that out myself. First thing you'll do is you'll check the geometry. So you want to make sure that that little cube is there with the check mark. That means your geometry is solid and it's not hollow. I had that problem. You click on it, it'll highlight it all green. Go here, make sure the materials is right, and it looks like it is, so we'll uncheck that. Next, what you're going to do is you're actually going to set up your experiment. So we're going to get our fixed points first. So you'll go to the environment tab. You'll make sure static structural is highlighted. You'll go to fixed, okay? This is where you're setting up your fixed points. So for my scenario, these plates here that are connected to this thing at the top are going to be screwed into a leg or to a wall or something like that. And this is what's going to be holding it up, holding whatever object up. So we'll basically hold control so you get multiple selections here. Make sure this is highlighted blue. You'll click there, and those will be your supports. So then you'll go to this, click apply, boom, two faces, those are your fixed points. You can see here the legend says that the purple, I believe, is that the color, or blue, is where your fixed supports are. So, and the way I'm moving this around is I'm just using middle click, and any point on the part, you can grab a different axis, your rotational point. And then if you want to move it like panning the screen, you hold control and use middle click, okay? So that's how I'm doing that. Now you have your fixed support there. So you click on this again, and then you'll go to your force. So you'll click force. There's two different types of forces you can apply. You can apply a vector force, which will basically apply a linear vector at that point. Or what I did is you'll basically put a distributed load over the top, which is probably what you'll do as well. But for something like Miko's scenario where he's pulling back a bow, you'd put a vector force and you'd set it to just in one axis. So in his case, it might be the z-axis that you'll just set the force there. But we want a component, so our component will be the y component because our vertical axis for our part is in the y. So we'll go here and convert whatever force you think is going to be displayed on here. So mine was about 3,000 pounds support, and there's going to be 4 of these brackets supporting that. So you divide 3,000 by 4, convert it to newtons. It's about 3,340 newtons. So we'll just type that in, press enter. Okay, and then we'll select our geometry. So this is already selected, but you'll just click that if it's not. Click apply. Now that selection will be red, and now it's a distributed load over that plane. Okay, now that's all set up. Now that you have your support and your force set up, you're going to go to your mesh. So you're going to highlight the mesh. So you don't even have to exit out of this or anything. It'll go right to it. Go to mesh, and then the book actually says to use an adaptive mesh, or is it adaptive? Yeah, I think so, or no. Is it? Right, I think it's adaptive sizing. So you want that on. And you'll go to mesh, you'll go to adaptive sizing, resolution, you'll set to 4. Okay, and then you'll just click generate. And now this is in the bottom left here, it'll show the progress of it meshing. Okay, now you have your mesh. Okay, now after you're done creating your mesh, and this symbol will change after the mesh is done, because now it's not a solid part, it's a meshed geometry, so it's a little bit different than it was before. And then you'll go to solve, and then it'll solve it for you. So it'll solve based on your supports and your forces, and boom, we're done. So the only problem is what I missed there is I didn't even set up anything for it to solve. So all it did was create the mesh again. So now we'll go to solution, and depending on what you want, you have all these selections up here at the top. So he wants maximum principal stress and equivalent stress. He doesn't specify deformation, but I always put it in there just because it's nice to look at, and you can maybe get some brownie points or kind of help you get 100 if you miss something. So I always put that in there. And then the last thing you want to do after you solve it is you'll apply a probe to it. But we'll do that after it's solved. So we'll click solve now that we have all those, and boom, it's done. So we'll have maximum principal stress. So all those red spots are the really hit spots. We have equivalent stress where the green areas are. Total deformation just shows where it's deformed the most. And then all you have to do here is instead of going to solution and going to probe, like here, you're actually going to click on the stress you're going to probe. So say we want principal stress, right? We want to find the max. So we'll hit maximum. It'll show where our max is. So up in this display window, you will hit maximum. It'll show where our max is. And then if you want to display the number of the force at that max place, you'll hit probe. And then it'll kind of give you a preview of what that force number is. And then if you click, it'll actually pin the force where that is. So our max here, if we zoom in, I think is probably that 411 point. So we'll hit that. Now it'll display it on our screen. So when we screenshot this, when we grab a screen grab, it'll show up there. You can do that for all the other ones too. So now it actually shows the max on each of these. And then we can also probe this one. So this one looks like it's actually on the underside of the material. So yeah, you can see it's right there. So we'll kind of zoom in here. And it looks like it's about 688 newtons, which is crazy. Or MPa rather. So again, we'll pin that. And then our deformation, we don't really have to pin, but if you want to, you could. And that basically just shows like the max deformation. So we'll hit that. and then we're good. So then you'll just screen grab all this. And then if you have a part that you designed or you want to explain the scenario, you can do that too. I actually did that in mine, so I'll show you mine real quick. Let's see. So FEA assignments, FEA 2 completed. Here we go. So this is what mine looked like. Designed the part myself, explained the scenario, the load type, and the max deformation, and then just the screen grabs of all those with the max points. Because he wants the probe, so definitely do the probe because it's required. But yeah, that's pretty much it, guys. All right. See ya.